Alright, so in this lesson we will complete the square. So complete the square given a trinomial with no variables in this case. So before we do this, let's figure out what a perfect square is first. Alright, so we got these perfect squares. Like 3 to the second power, 3 squared is 3 times 3, which is 9. So this 9 is a perfect square because 3 times 3 is 9. 4 squared is 4 times 4, which is 16. That means that 16 is a perfect square because 4 times 4 is 16. I don't know why I can't write that 6. Alright. Y squared is y times y, which is y squared again. So, of course, y squared is a perfect square because y times y is y squared. And w squared, which is w times w, is w squared, obviously. It's kind of redundant, right? But I just wanted to show you that it works with variables as it does with other numbers. So w squared is a perfect square because w times w is w squared. Alright, so let's talk about perfect square trinomials. So remember, perfect squares, they're going to be the same thing times the same thing. So for instance, we have 3 plus 4 squared, which is 3 plus 4 times 3 plus 4, which is, 3 times 3, 3 times 4, 4 times 3, 4 times 4. We get this, whatever. So we get 9 plus 12, so 3 times 3 is 9, 3 times 4 is 12, 4 times 3 is 12, 4 times 4 is 16. And then if you notice, we put the middle terms together, like the 3 times 4 and the 4 times 3. We put them together, we get 24. So we know that 9 plus 24 plus 16, I run out a little bit of room, maybe I could do that a little better. 9 plus 24 plus 16 is a perfect square because 3 plus 4 times 3 plus 4 equals 9 plus 24 plus 16. Like in this one, we have 5 minus 2 squared, which is 5 minus 2 times 5 minus 2. So 5 times 5 is 25. 5 times minus 2 is minus 10. Negative 2 times 5 is negative 10. And negative 2 times negative 2 is positive 4. And remember, I put these two middle terms together. Minus 10 is minus 20. For now, we could just do 25 minus 10 plus 4 and get an answer, right? But this is going to help us with our future lessons. So I want to just show you. We're just putting the middle terms together. It'll make more sense tomorrow, okay? Or in the next lesson. So we know that 25 minus 20 plus 4 is a perfect square trinomial because 5 minus 2 times 5 minus 2 equals 25 minus 20 plus 4. Easy enough, right? And lastly, I'm showing you with both terms are negative. So negative 4 minus 5 squared is negative 4. Minus 5 times negative 4 minus 5. So negative 4 times negative 4 is positive 16. Negative 4 times negative 5 is positive 20. Negative 5 times negative 4 is positive 20. Negative 5 times negative 5 is positive 25. So we know that this 16... Oh, then we put these terms together. The two middle terms. So we get 16 plus 40 plus 25. I ran out of room. Okay, there we go. Put those together. So we get 16 plus 40 plus 25. We know that that is a perfect square trinomial because negative 4 minus 5 times negative 4 minus 5 equals 16 plus, or can be expressed as 16 plus 40 plus 25. Okay, now, before we move on, we know what a perfect square is, right? It's this answer or the product of the same thing times the same thing. Like we multiplied these, we got this. This is our answer, right? Trinomial, we call it a trinomial because there are three terms. 1, 2, 3. There are three terms. 1, 2, 3. There are three terms. 1, 2, 3. So these are perfect squares because you multiply the same thing. You can express it as that. And it's three terms. So it's trinomial, three terms. 1, 2, 3. So let's talk about, there's this pattern. I think some of y'all are seeing some of this pattern, but we just need to make sure we can express this pattern. So this first term right here, I'm going to do like this. So this first term right here, the 9, the 25, the 16. Now I want you to look at this. So I made this a into 3, this b into 4, this a into 5, this b into -2, this a into -4, this b into as -5, right? So how do I go from this 3 plus 4? How do I go from this 3 to this 9? How do I go from this 5 to this 25? How do I go from this -4 to this positive 16? Well, it's literally like 3 times 3 is 9. Like 3 times 3 is 9. 5 times 5 is 25. -4 times -4 is positive 16. So if that's a, then the first term is a squared. It's the same thing times the same thing, like 3 times 3. Now, if you look at the end, we have the 16. We can do this 4 squared. 4 times 4 is 16. -2 squared. -2 times -2 is positive 4. -5 times -5, or -5 squared, is positive 25. So you can tell that this last term, this third term right here, this last term here, this last term here, we can always tell that it is, well, it's always b squared. It's always b times b. Those are easy. Now, how do we get this middle one? I'm actually going to change this color. How do we get this middle one? This positive 24, this -20, this positive 40. Well, if you look here, there are two of these, right? There are two of these. There are two of these. There are two of this 3. Like when we did 3 times 4, we got 12. We did 4 times 3, we got 12. Over here, we had a 5 and a -2. So we did 5 and -2 is -10. -2 and 5 is -10. In this one, -4 times -5, -4 times -5, or what's it like? -4 times -5 is positive 20. -5 times -4 is positive 20. If you notice, it's always, you're multiplying these two numbers, you're multiplying these two numbers, you're multiplying these two numbers twice. Because look, you're multiplying it twice here and here, well, right there. And you're multiplying it here and here. You're multiplying those two numbers right here and right here. So there's always two of them. So there are always two a times b's. And this will become more clear as we go. So this first number here is 3 times 3, which is 9. This is 4 times 4, which is 16. 3 times 4 is 12, but there's two of them, so we get 24. So 5 times 5 is 25. -2 times -2 is positive 4. -2 times, well, 5 times -2 is -10, but there's two of them. There's two of them, so we get -20. So we should be able to do this very quickly. But before we do, let's actually go ahead and do this. So a plus b to the second power, a quick way of doing it would be that this is going to be a squared, this will be b squared, and this middle one will be 2ab. Oh, I meant to change colors. Plus 2ab. And I guess I should put a plus there for the b squared. Is that better? Yeah. So let's just go ahead and start getting some answers. So like 3 plus 4 squared. 3 times 3 is 9. 4 times 4 is positive 16. 3 times 4 is 12. There's two of them though, so we get 24. Positive 24. So this one, 4 times 4 is 16. 5 times 5 is 25. Positive 25. We get 4 times 5 is 20, but there's two of them, remember? So it's a positive 40. Let me correct that. Make it look more like a 6, I guess. I guess that's good enough. So 2 times 2 is 4. 3 times 3 is positive 9. 2 times 3 is 6, but there's 2 of them, so we get positive 12. Not too bad. 3 times 3 is 9. Negative 2 times negative 2 is positive 4. And 3 times negative 2 is negative 6, but there's 2 of them, so I get negative 12. I should write that a little bit better. All right, so 5 times 5 is 25. Negative 4 times negative 4 is positive 16. 5 times negative 4 is negative 20, but there's 2 of them. 5 times negative 4 is negative 20, so there's 2 of them, so we get negative 40, so minus 40. One more. So negative 4 times negative 4 is positive 16. My 6's just look funky. Negative 3 times negative 3 is positive 9. Negative 4 times negative 3 is negative, it's positive, right? Negative times negative is positive, positive 12, and there's 2 of them, so we get plus 24. All right, cool, let's go to the next page. So, on this page, I'm going to give you, the missing middle term of the trinomial. We got to find it. It's not really that difficult, right? Well, you'll see. Let's do blue. So we know that A plus B squared is A plus B times A plus B, which is A squared plus 2AB plus B squared. Okay, so we know that this is A squared. So the square root of 9, I guess I'll put it over here. Square root of 9 is 3, right? So we know that this is 3. And we know that the square root of 16 is 4. So that's going to be plus 4, which means this is 3 plus 4 times 3 plus 4. Because remember, 3 plus 4 squared is 3 plus 4 times 2 plus 4. So we know that this middle term is 2AB, right? So 3 times 4 is 12. We have 2 of them, so plus 24. That's really not bad, right? But this is actually, we can have, different answers. It's just, the square root of 9 is not just 3. 3 times 3 is 9, yes, but negative 3 times negative 3. So this is actually, let me put this in a different color. Square root of 9 is actually positive 3 and negative 3. The square root of 16 is actually positive 4 and negative 4. So we can actually say that 3 plus 4 squared is 3 plus 4 times 3 plus 4, which is 9 plus 24 plus 16. But we could also say that the square root of 9, instead of using positive 3, we could use negative 3. And positive 4, so that's negative 3 plus 4 squared is negative 3 plus 4 times negative 3 plus 4. Okay, because when I do this negative 3 times negative 3, I will get 9. When I do this positive 4 times positive 4, I will get 16. But then this middle one, so this negative 3 times 4 is negative 12, and 2 of them would be negative 24. So I could also just say that this was a positive 3, the square root of 9 was positive 3. I could say that this square root of 16 was negative 4, so 3 minus 4. Make that a little bit nicer. So 3 minus 4 to the second power. 3 minus 4 squared is 3 minus 4 times 3 minus 4. And I can tell 3 times 3 is 9. This negative 4 times negative 4 is positive 16. But this 3 times negative 4 is negative 12. There's 2 of them, so I get negative 24. And lastly, I could actually say that both of these were negative. I could do negative 3 and negative 4. Squared is negative 3 minus 4 times negative 3 minus 4. I can show it because negative 3 times negative 3 is positive 9, and the last step would be negative 4 times negative 4, which is positive 16. So negative 3 times negative 4 is a positive 12, and there's 2 of them, so it's positive 24. Cool. Not too bad.